Hi HMS modelers, this is Matt Fleming from the Hydrologic Engineering Center. And in this video, I'm going to talk about subbasin discretization, or how you break up your subbasin elements to model different hydrologic processes in HMS. So this is a really fun topic, and it's somewhat complicated. With version 4.7, so if you've used older versions of HMS, you're going to remember that if you wanted to use gridded modeling, you'd have to use a mod Clark grid cell file. But with version 4.7 and newer, the idea of discretization comes in, and it's really about how you're going to break up the basin model. And so if you look at this figure on this slide, we have a watershed here, and discretization could mean many things, right? So we could have one subbasin here that represents the entire watershed. And so that would be just one simple subbasin element. Or you notice here in what we actually see in front of us, we have three subbasins. So I could subdivide or discretize that watershed from one subbasin to three subbasins, and HMS is going to let you do that. Another option is you could take the watershed and break it up into 20 subbasins or 40 subbasins or 100 subbasins. You get to choose how you're going to represent the watershed. And so in addition to subdelineating the subbasins, HMS also allows you to define a grid or a mesh that you overlay on top of the subbasin elements. And then that grid is used to get information like gridded precipitation. So if you have radar rainfall, satellite information, you could apply that, and that grid that you define, that discretization of the subbasin elements, is used to intersect those cell centroids with that meteorologic data to determine the representative value for that cell. In addition to the meteorologic data, you could also use different gridded loss methods. And so you could use a gridded deficit and constant method where you vary your percent impervious area or your constant loss rate throughout the subbasin. So instead of having one subbasin average value, you could have a varying value across that subbasin element. And then for the transform methods, you can use a simple unit hydrograph method, so that what that does is that for those losses, if you use Clark unit hydrograph, so the program's going to take those losses, it's going to compute the basin average loss, the basin average excess, and then that excess is applied to the unit hydrograph method. Well, in addition to the unit hydrograph method, you have other transform methods. You have the mod Clark method, which uses excess for each of those grid cells that you define, and then routes that excess precipitation to the subbasin outlet. Not from cell to cell, but from that cell to the outlet using a very simple linear reservoir. The other option is the 2D surface flow option. So if you do want to use 2D surface flow, then you can choose a unstructured discretization method in HMS and then apply that gridded precipitation to the mesh or the unstructured mesh. All right, so let's jump into it. So the discretization method is defined on the main component editor for a subbasin element. And so I have, this figure shows the subbasin element right here. So the basin name is Mahoning Creek. This subbasin element is named Mahoning Creek Local. And you can see the area for the subbasin, latitude and longitude coordinates for the centroid of the subbasin. And then the first option that you choose right here is the discretization method. And so you have a couple of options. The none option is a legitimate option. So if you choose the none discretization method, then you're going to use basin average rainfall or rain gauges. The program's going to compute basin average rainfall if you use rain gauges, and then apply unit hydrographs, basin average losses, basin average excess, and so on. So with the none discretization method, you're going to lump all those processes across the watershed or across that subbasin element and compute the lumped or the subbasin average information. Then you have the structured method. And so what the structured method means is the program's going to create either a standard hydrologic grid or a UTM grid. You get to choose which projection, which grid you want to use. You get to choose the cell size for that grid. The program will intersect the grid with those subbasin elements, and then you could apply either gridded precipitation to those, average precipitation to those structured discretizations. You can also do gridded loss methods with the structured discretizations and then the Mod-Clark transform method. The unstructured option, this is for the 2D flow. So if you're going to import the mesh from a RAS 2D model, then you would import that into HMS and then make sure that you have selected the unstructured discretization method. And finally, the file specified method. So that's where if you still want to use the older Mod-Clark grid cell file, so that's the grid cell file that's created by HEC-HMS. So if you still want to use that file in version 4.7 and newer, you can. You would just choose this file specified option. And once you do, you'd have to make sure that you link up for that subbasin element or this subbasin element that we have on this figure or example, make sure that you're linking it to the correct Mod-Clark or grid cell file. All right. So as I mentioned, the structured discretization, you get to choose the projection that you want to use. You can choose SHG, this stands for the standard hydrologic grid, and that uses the Albers equal area projection, or the UTM grid. That's going to be your worldwide grid. So you could use, if you're modeling a watershed outside of the US, then you want to make sure that you're using the UTM grid option. And then you have to specify a different additional information about the grid. So are you in a specific zone of the UTM system? And then are you in the northern hemisphere or the southern hemisphere? And as I mentioned too, the unstructured option, that's for importing those HEC RAS 2D meshes into the HMS project. All right, so you see here, once you choose the discretization method, and in this example right here, I chose the structured discretization method, you would go to the discretization tab within the subbasin component editor. So it's going to look like this. By default, the program is going to link to the SQLite file that has the same name as the basin model. And then you get to choose the projection. So in this example, I chose the standard hydrologic grid projection, and then the cell size right here is 2 kilometers. You can choose from among many different cell sizes. The nice thing about version 4.7 of HMS as well is you can choose different cell sizes per subbasin elements if you wanted to. So you don't choose just one cell size for all subbasin elements. You could choose 200 or 2,000 meters for one subbasin, 10,000 for another, and so on. With the new discretization method, the structured method, the program will compute the grid for you, and then it's going to intersect the grid with your subbasin elements, compute the cell area. So for each of those cells that intersect the subbasin, define or compute the cell area, and then also the travel length. And again, that travel length is going to be important for the Mod-Clark transform method. And as that last bullet says right there, so the travel length is going to be computed as the average value per cell. And so what you might have is with your flow direction, flow accumulation grids, you have lots of cells, because that's based on your original terrain model, that fall within the cell that represents the discretization. So if I'm using my 2,000 meter SHG, then each of those cells that are within the subbasin, they are 2,000 or really 4 kilometers, square kilometers in size. So you can imagine there are quite a few cells from the terrain model that lie within that 4 kilometer grid cell. And the program will compute the average value when it uses the travel length, computes the travel length. All right, so we'll go to this slide right here. And whenever you do select the discretization method, the next step is to go to the GIS menu and choose an option to compute the grid cells. And once you compute those grid cells, you'll be able to display the grid on top of the basin or within the basin model map. And so you can see in this figure right here, here's my 2 kilometer grid displayed within the basin model map. Again, each of these cells is 2 kilometers by 2 kilometers, so the total area of the cell is 4 square kilometers. And you can turn on and off the discretization layer from the map layers editor right here. So in order to compute those, the discretization, so you see on this slide right here, this is the GIS menu, and come down here, compute, and then you'll see a secondary menu right here. There should be an option for compute grid cells. Once you choose that option and you have the discretization layer turned on in that map layers editor, you should see those grid cells displayed across the basin model. And so what we have on this slide right here, this shows you an option to use HMS, newer versions of HMS, to create that structured discretization for those projects that were created prior to version 4.7. And so there's just a couple of steps that you have to follow. So let's say you had an existing project and you've georeferenced those elements using shapefiles. And so once you have done that, then what you want to do is, that's step one, georeference those subbasin elements. Step two is to load a terrain model into your project. So you have to have that terrain data set loaded into the basin model. You want to run the pre-process sinks and then pre-process drainage steps so that the program computes the flow direction grid. And once that flow direction grid has been computed, then you can jump down to the compute grid cells tool, and the program will automatically create that mesh, overlay the mesh within the subbasin elements, and then compute the travel length for you. So you don't have to run through identified streams, define your breakpoints, and delineate elements. All you need is that flow direction grid, and then you can have the program create that structured discretization for you.